Welcome to the University of Plymouth. Behind me is the Davy building, which houses all the chemistry labs. I'm going to take you inside now and show you all the work that we do and the instrumentation we use to do it. Welcome to the Davy building. This is our newly refurbished science facility. This building is a flagship leading the way for the Faculty of Science and Technology. This is the ISO accredited atomic spectrometry lab, which you will be using in your second and third year, and mainly in your third year for project work. I use the ICP just down the corridor, which is my own personal one. This is an inductively coupled plasma mass spectrometer, which I'm using as part of my third year project. I'm working in collaboration with industry with a company called Thermo Fisher, and together we're trying to understand and analyse the analytical capabilities of the instrument. It can detect down to really small levels, part per trillion. So basically, if you think about it, like trying to find a grain of sand in an Olympic-sized swimming pool, which is really good at the moment. This is the whole reason why I came to Plymouth, because you get a lot of hands-on time with the instruments. So when you go out into the real world after, these instruments are used every day, so you know what to do, and it's the whole reason why I came to Plymouth. In order to perform our measurements, we need a very hot source. In front of you is a plasma, which gets up to the same temperature as the surface of the sun. This means that any sample which is induced with ITP is very efficiently atomized. This is our brand new mass spectrometry facility, which houses a lot of different mass spectrometers, as you can see. This is my colleague Charles. Charles, can you explain to us the research you're conducting at the moment?
We conduct a lot of research here at the University of Plymouth. For example, here we have a gas chromatograph mass spectrometer. So I'm analysing an environmental sample from the Gulf of Mexico spill. So we have the sample injected here, and then it passes through a column which separates all of the vast variety of components, and then goes to the detector, which is the mass spectrometer, and then I interpret the data that's output by the instrument.
This is another one of our research labs down on the first floor of our university block. This is my colleague Josh. Josh, can you explain to us the research you're conducting today?
I am a third year student doing my dissertation on developing a method of HPLC for the determination of codeine, paracetamol and their metabolites in fake human urine. Yeah. I was recommended by the RIC when I was applying for universities that Plymouth University have a very good hands-on experience with the instruments, which looks very favourable when applying for jobs rather than learning how to use them out of the book.
This is Chris, a colleague of mine who I've been really good friends with since first year at the university. Chris, can you tell us about the research you're doing today?
Yes, at the moment I'm doing my third year project, which is looking into trace elements in the River Plym. So what I've done is I've taken samples from along the river, I've processed them, and I'm going to input them into this instrument here. Now this is a flame atomic absorption spectrometer. So basically I've got a known amount of magnesium at the moment, so in this case 0.1 micrograms per litre. What we do is we get a calibration graph, and we put our unknowns in, and from that we'd be able to work out exactly what is in our sample.
This is a second year chemistry laboratory. We're here with the module leader today, Dr. Mark Fitzsimons. Mark, can you tell us a bit more about the lab today?
Well, Laura, in organic chemistry, like all the modules, we try to link theory and practice. So this week the students are doing a new experiment involving a distillation. They're using a demon starch trap for particle synthesis, and they're making an enamine, and this is one of the molecules we're particularly interested in during the lecture series. So again, we're trying to link theory and practice as much as we can.
Another colleague of mine is Rachel. Rachel is working along the pharmaceutical company AstraZeneca, who are sponsoring her project. Rachel, can you tell us about the work you're doing today?
So this is my project. It's in link with AstraZeneca. It's to do with when you take an aspirin, only about 30 to 70% of it is actually absorbed into the body. The rest leaves you in your urine, and this goes into waste disposal plants and then goes into the environment. Now this affects the environment and the way animals will breed in the future. I'm going to present my findings to AstraZeneca at the end of the project so that they can continue with this method, as it's a method they don't use at the moment.
Rachel, why did you choose to come to Plymouth University out of everyone else?
Well, I came here on an open day and looked around and talked to some of the lecturers. I absolutely loved it. I put it down as my first choice and luckily I got in.
We're here at Wembury Beach, which is only a 15-minute drive away from the university campus. This is where the second year fieldworks take place.
Another one.
Now we're back from the Wembury field trip. Jack and Jordan are going to explain to us how the samples were pre-treated before analysis.
Alright, well, I've got my sample here. I got it from next to the stream, and I'm going to grind it up in here. And then I'm going to filter it out with this. So I get some big bits, some medium-sized bits, and some very fine stuff, which I'm going to dissolve in some acid later on to get something like this, which I produced earlier.
I've collected 2 samples from the river. One has been filtered, one hasn't. I've spiked them both with acid, so they can be ready for sampling in smaller amounts.